Tesla's LFP batteries have been making waves in the electric vehicle market. These batteries are known for their affordability and robustness. However, recent tests have revealed some surprising results about their long-term durability. These findings have sparked a debate among Tesla owners and enthusiasts. It is crucial to examine these findings and understand their implications for the future of LFP batteries in electric vehicles. The unexpected degradation observed in these batteries raises questions about the effectiveness of Tesla's charging recommendations. Furthermore, these results have ignited a discussion about the long-term viability of LFP batteries as a sustainable option for electric vehicles. LFP batteries, or lithium iron phosphate batteries, are a type of lithium-ion battery that offers a unique set of advantages. These batteries are increasingly being used in various applications, from electric vehicles to energy storage systems, due to their robust performance and safety features. They are known for their thermal stability, making them a safer option compared to other lithium-ion chemistries. This stability is particularly important in high-temperature environments, where other batteries might pose a risk of overheating or even catching fire. Additionally, LFP batteries boast a longer lifespan in terms of charge cycles. This means they can be charged and discharged many more times than other types of lithium-ion batteries before their capacity starts to degrade significantly. This means they can withstand more charge and discharge cycles before experiencing significant degradation. For electric vehicle owners, this translates to a longer-lasting battery that requires less frequent replacement, ultimately reducing the total cost of ownership. Tesla, a leading electric vehicle manufacturer, has adopted LFP batteries in some of its models, particularly the Model 3 RWD. This decision aligns with Tesla's commitment to safety, longevity, and sustainability in their vehicles. Tesla recommends that owners of vehicles with LFP batteries charge them to 100% regularly. This practice is somewhat different from the recommendations for other types of lithium-ion batteries, which often suggest avoiding full charges to prolong battery life. This advice stems from the unique charging characteristics of LFP batteries. Unlike other lithium-ion batteries, LFP batteries do not experience the same level of stress when charged to their full capacity. This makes them more resilient and capable of maintaining their performance over time. Unlike other lithium-ion batteries, LFP batteries do not experience the same level of stress when charged to their full capacity. This unique property allows them to be charged to 100% without the risk of significant degradation, making them ideal for daily use in electric vehicles. Tesla believes that frequent 100% charges can help calibrate the battery management system, ensuring accurate range estimates and optimal performance. By regularly charging to full capacity, the system can better understand the battery's state of health and provide more reliable data to the driver. While Tesla advocates for regular 100% charging of LFP batteries, this recommendation has been met with skepticism and concern from some quarters. Tesla's advice is based on the unique chemistry of LFP batteries, which are known to be more resilient to high charge levels compared to other battery types. However, this has not quelled the worries of many Tesla owners and experts in the field. Critics argue that consistently charging to 100% can accelerate battery degradation over the long term. They point to the fact that all batteries experience some degree of stress when held at their maximum voltage for extended periods. This stress can lead to a reduction in the overall lifespan of the battery, which is a significant concern for electric vehicle owners who rely on their battery's longevity. The debate is further fueled by the lack of long-term data on the impact of frequent 100% charging on LFP batteries. While some studies suggest that LFP batteries can handle higher charge levels better than other types, the real-world implications over several years of use remain unclear. This uncertainty has led to a split in the Tesla community. Some Tesla owners, adhering to the manufacturer's advice, diligently charge their vehicles to 100% on a regular basis. They trust that Tesla's recommendations are based on rigorous testing and data analysis. These owners believe that following the guidelines will ensure optimal performance and range for their vehicles. Others, however, remain cautious and prefer to limit their charging to 80% or 90% to potentially mitigate the risk of accelerated degradation. They argue that even if LFP batteries are more resilient, it is better to err on the side of caution to preserve battery health and longevity. This concern has led to a debate among Tesla owners about the best charging practices for their LFP-equipped vehicles. The differing opinions highlight the broader issue of how best to manage battery health in electric vehicles, a topic that is still evolving as more data becomes available. This difference in charging habits reflects the ongoing uncertainty surrounding Tesla's recommendations and the lack of definitive long-term data on the impact of frequent 100% charging on LFP batteries. As the electric vehicle market continues to grow, it is likely that more research will be conducted to provide clearer guidance on this issue. Until then, Tesla owners will continue to navigate this complex landscape, balancing the need for convenience and range with the desire to maintain their vehicle's battery health for as long as possible. The debate over the best charging practices for LFP batteries is a microcosm of the larger challenges facing the electric vehicle industry as it matures and evolves. Kyle Connor, a well-known electric vehicle enthusiast and YouTuber, recently conducted a long-term test on a Tesla Model 3 RWD equipped with an LFP battery. This test was part of his ongoing efforts to provide the EV community with real-world data and insights into the performance of various electric vehicle technologies. Connor meticulously documented the battery's performance over an extended period. He tracked various metrics including charging efficiency, range consistency, and overall battery health, to ensure a comprehensive analysis. His findings revealed an unexpected level of degradation, even when following Tesla's recommended charging practices. This was particularly surprising given the reputation of LFP batteries for their supposed durability and stability. The test results showed a noticeable decrease in the battery's capacity, exceeding the typical degradation rates observed in other Tesla models. This raised eyebrows within the EV community, as LFP batteries were expected to perform better in terms of longevity. These findings have significant implications for the perception of LFP batteries, particularly their long-term durability. The data suggests that while LFP batteries may offer certain advantages, they are not immune to the challenges faced by other battery chemistries. Connor's test, while conducted on a single vehicle, raises questions about the overall longevity of LFP batteries in real-world use. It highlights the need for more extensive testing across a broader range of vehicles and conditions to draw definitive conclusions. The results challenge the prevailing notion that LFP batteries are inherently more durable and less prone to degradation than other lithium-ion chemistries. This could lead to a re-evaluation of how these batteries are marketed and perceived by consumers. This unexpected outcome has sparked a wave of concern among Tesla owners and potential buyers who were drawn to the LFP battery's perceived advantages. It underscores the importance of ongoing research and transparency in the rapidly evolving field of electric vehicle technology.